you guys, this is Mr. Millings, and in this video we are going to be doing some MassMass Stoichiometry problems. And before we start doing these MassMass Stoichiometry problems, here's a little disclaimer. It says,
prior knowledge is necessary before watching these videos, and I suggest that you watch the video on balancing chemical equations and calculating molar mass, or you will be lost.
So let's jump right in and take a look at some MassMass Stoichiometry problems. Let's work some of these problems out together, and then at the very end you will work on some on your own. So let's take a look at what MassMass Stoichiometry problems entail. It says right here that a MassMass stoichiometric calculation is the process of figuring out the mass, usually in grams, of one substance in a chemical equation based on the mass, usually in grams, of another substance in the same chemical equation. So what the heck does all this mean? Well, essentially a MassMass stoichiometry problem consists of you trying to figure out the mass of one other substance in the chemical equation when you are given the mass in grams of a different substance in that chemical equation. For example, if we take a look down here, we've got 4 moles of potassium oxide reacting with 2 moles of carbon dioxide. And this is going to end up producing 2 moles of potassium carbonate and 3 moles of oxygen gas. And so what if we have 125 grams of this stuff here reacting with 230 grams of this stuff here, and we want to figure out the mass in grams of potassium carbonate that will be produced and the mass in grams of oxygen gas that will be produced? Well, we would have to do some MassMass stoichiometry. And if we take a look at this little flow chart here, this little flow chart will help you when you are working on some MassMass stoichiometry problems. But essentially on the left hand side, this is the known substance, or substance A, expressed in grams. We will then convert it to moles. We will then multiply by the mole ratio. This little step right here allows us to go from the known substance to unknown substance, or substance A to substance B, and then last we'll convert that back to grams. So let's apply this little flow chart to several different example problems, and then at the end you can work on some problems yourself. In this first example, it says in the reaction below, if 265 grams of calcium chloride reacts with an excess of silver nitrate, then what mass of silver chloride will be produced? So usually in a MassMass stoichiometry problem, it is a word problem, but don't be scared. What I like to do is take this little word problem here and break it apart. It says right here we have 265 grams of calcium chloride. So we have 265 grams of this stuff right here reacting with an excess of silver nitrate. This just means that we have an unlimited amount of this. It's not going to limit our chemical reaction from taking place. So we just have a lot of this, an unspecified amount of this. And we want to figure out what mass of silver chloride will be produced in this chemical reaction right here. So the first thing that we have to do whenever we do a stoichiometry problem is we have to balance the chemical equation. So let's go ahead and balance this chemical equation. Our chemical equation should now be balanced. And so we can go ahead and start our stoichiometry process. In this problem here, the known quantity, or substance A, is 265 grams of CaCl2, right? That's the known starting quantity. And so the very first thing that we're going to have to do with this is we're going to have to convert the mass of the known substance in grams. We're going to have to convert this to moles. And the way that we convert mass to moles, or grams to moles, is by dividing by the molar mass of the substance you're dealing with, which is the CaCl2 here. And so we know that 1 mole of CaCl2, and hopefully you have a calculator out and your periodic tables so that way you can determine the molar mass of this. We know that 1 mole of CaCl2 is going to end up being 110.98 grams. And if you forgot how to calculate a molar mass, I suggest you click the little card that just appeared in the top right hand corner and watch the video on how to calculate a molar mass. So now we're here in this process, but we want to figure out how many moles of the unknown substance there are in our balanced chemical equation. So we have to come up with a mole ratio. And if you remember, a mole ratio compares two things in the chemical equation. In this case here, it's comparing the stuff you're trying to find to the given stuff over here. So if we take a look, what this chemical equation is telling us is that for every 2 moles of AgCl, there is 1 mole of CaCl2. Okay, so bam, that's this step right here, the mole ratio step. Last but not least, we don't want our answer in moles, we want it in grams. So we have to take this one step further. We have to multiply by the molar mass of AgCl, which is 143.32. 143.32 will go on top since we're multiplying by this grams of AgCl for every mole of AgCl. So bam, we have this set up. Now let's take a look at what cancels. We have grams of calcium chloride on top and bottom. They will cancel. Moles of calcium chloride on top and bottom. They will cancel. Moles of silver chloride on top and bottom. They will cancel, leaving us with grams of AgCl, which is what we were trying to find. So now we just plug this into our little calculator. We take 265 divided by 110.98 times 2 times 143.32, and if we take a look, our answer can only contain 3 significant figures here, and it looks like we are going to end up with 684 grams of silver chloride will be produced. So if we have 265 grams of calcium chloride reacting with an excess of this, it's going to end up producing 684 grams of silver chloride. Let's take a look at another example. In this example, it says in the reaction below, how many grams of magnesium oxide will form from 55 grams of magnesium and an excess of oxygen gas. So in this problem here, it looks like we have 55 grams of magnesium, and what we want to figure out is how many grams of magnesium oxide will end up being produced. So we have to balance our chemical equation first. And so bam, our chemical equation is now balanced. And so if we take a look at the known substance, or substance A, it looks like we have 55 grams of magnesium. And so what we want to do with this is we want to figure out how many grams of magnesium oxide will end up being produced here. So the first thing that we have to do is we have to convert the grams of magnesium to moles of magnesium by dividing by the molar mass of magnesium. We know that 1 mole of magnesium is 24.31 grams of magnesium. Step 1 is done. And the next step, what we now need to do is we need to find the mole ratio of the stuff that we're trying to find and compare it to the given stuff in the chemical equation. It looks like there are 2 moles of magnesium oxide. 2 moles of magnesium oxide for every 2 moles of magnesium. There's our next step that allows us to go from moles of known substance to moles of unknown substance. And last but not least, we are trying to figure out the mass in grams of this unknown substance. So what we now have to do is multiply by the molar mass of magnesium oxide. The molar mass of magnesium oxide, if you have your periodic tables out and your calculators, is going to end up being 40.31. 40.31 grams of MgO for every mole of MgO. So now that we've shown our work here, we can get our calculators out and plug it in. We have 55. We're going to divide this by 24.31. We're then going to multiply by 2 and divide by 2, which cancels out and essentially is 1. And then we're going to multiply by 40.31. And we should end up with a final answer, keeping in mind 2 significant figures must be used here. 91 grams of MgO. Take a look. Grams of magnesium on top and bottom cancel. Moles of magnesium on top and bottom cancel. Moles of magnesium oxide on top and bottom cancel, leaving us with grams of magnesium oxide, which is what we were trying to find. So if you have 55 grams of magnesium here reacting with excess excess oxygen, it's going to end up producing 91 grams of magnesium oxide. Let's take a look at another problem. In this problem, it says in the reaction below, you've got 5.0 grams of water reacting with excess aluminum carbide to yield what mass of aluminum hydroxide. So in this problem here, it looks like we have 5.0 grams of water, and it's going to react with excess aluminum carbide here. And what we want to do is we want to figure out how many grams of aluminum hydroxide will end up being produced. So first thing that we have to do is we have to balance this chemical equation. So it looks like it's going to be 12 waters, 3 moles of methane here, and 4 moles of aluminum hydroxide is going to balance this chemical equation. So now what's the starting stuff? We're starting with 5.0 grams of water, and what we want to do is we want to figure out how many grams of aluminum hydroxide are going to end up being produced. So let's run it through the stoichiometry process here. First thing that we have to do is divide by the molar mass. Divide by the molar mass of water. We know that there are 18.02 grams of water for every mole of water. Step 1 is done. Now what we need to do is we need to make a comparison between the stuff that we're trying to find and the known stuff. If we take a look, this is the stuff that we're trying to find. Here's the known stuff right here. We've got 4 moles of aluminum hydroxide. 4 moles of aluminum hydroxide for every 12 moles of water. 12 moles of H2O right here. Right, there's our mole ratio step, and then the last step, what we need to do is convert the moles of aluminum hydroxide to grams of aluminum hydroxide. So how do we end up doing that? We multiply by the molar mass of aluminum hydroxide, which is 78.01. For every 1 mole. 78.01 grams for every mole of aluminum hydroxide. And if you're wondering where we got this 78.01, we took aluminum's molar mass and then added the molar mass of 3 hydrogens and 3 oxygens from the periodic table of elements. And so now we'll take our calculators and put this all in here. We'll take 5.0 divided by 18.02 times 4 divided by 12 times 78.01, and we end up with a grand total of 7.2. 7.2 what? Well, let's see what cancels out. We've got grams of water on top and bottom that cancel. Moles of water on top and bottom that cancel. Moles of aluminum hydroxide on top and bottom, leaving us with grams of AlOH3 as our final answer. So if we have 5.0 grams of water reacting with an excess of aluminum carbide, it's going to end up producing 7.2 grams of aluminum hydroxide. Holy shnikes, people. Let's try another problem. In this problem, it says in the reaction below, you've got 135 grams of calcium phosphide. And this is going to react with an excess of water. Then what mass of calcium hydroxide will form? So in this problem here, we have 135 grams of calcium phosphide. So we have 135 grams of this stuff right here. And we are asked to figure out how many grams of this stuff will be produced if this is reacting with an excess of water. So the first thing that we have to do is balance our chemical equation. And so there is our balanced chemical equation. Now we're starting off with 135 grams of Ca3P2. That's the known quantity. And what we are trying to do is we want to figure out how many grams of calcium hydroxide will be produced. So the first thing that we have to do here is divide by the molar mass of this stuff right here to convert the grams of it to moles. So we know that 1 mole of Ca3P2 is 182.18 grams of Ca3P2. How did I get this number? I pulled out my periodic table. I took the mass of calcium, multiplied it by 3. I took the mass of phosphorus, multiplied it by 2, and added those together. In the next step, we have to come up with the mole ratio. What is our mole ratio going to be here? Here is the unknown stuff. Here is the known stuff. Here it looks like it's a ratio of 3 to this imaginary 1. So we have 3 moles of calcium hydroxide for every 1 mole of calcium phosphide. There we go. There is that step right there. Next step, we have to convert these moles of calcium hydroxide to grams by multiplying by the molar mass of calcium hydroxide. Molar mass of calcium hydroxide is 74.10 grams for every 1 mole. So now we take our calculator out and we get, or rather we plug in 135 divided by 182.18 times 3 times 74.1. And we end up with the final answer of, if we have 3 significant figures here, our answer must contain 3 sig figs, 165 what? Well, grams of calcium phosphide are going to cancel. Moles of calcium phosphide are going to cancel. Moles of calcium hydroxide cancel, leaving us with grams of calcium hydroxide, which is exactly what we were trying to find. All right, so if you got 135 grams of this reacting with an excess amount of water, it's going to produce 165 grams of calcium hydroxide. Let's take a look at one more, people. This last example, it says in the reaction below, what mass of water? So we are asked to figure out the mass of water that will form from an excess amount of oxygen gas reacting with 50.0 grams of hexane. So we've got 50 grams of this stuff right here, or 50.0 grams of this stuff right here. And what we want to figure out is the mass of water that will be produced. So we have to balance our chemical equation first. And so let's go ahead and balance that right now. Our chemical equation is now balanced. So what are we starting with? What's the starting material? We have 50.0 grams of C6H6. And we want to know how many grams of water will end up being produced. So let's run it through the process here. Let's take a look. First thing that we have to do is divide this by the molar mass, right? We want to go from grams to moles. We divide by the molar mass. 1 mole of C6H6 is 78.12 grams. Of C6H6. That step is finished. Now what we have to do is come up with our mole ratio. What is our mole ratio of the stuff that we're trying to find to the known stuff over here? It looks like it's going to be 6 moles of water to 2 moles of C6H6. There's that step. That's done. Last thing, we need to convert the moles of water to grams of water, right? So we do that by multiplying by the molar mass of water, which is 18.02 grams per mole. There we go. That's how you're going to set this problem up. So now you take your calculator out, and we'll take 50.0 divided by 78.12 times 6 divided by 2 times 18.02, and we should end up with a final answer of, let's see, we have 3 sig figs here. Our answer must only be 3 sig figs, 34.6 grams of water. Grams of C6H6 cancel. Moles of C6H6 cancel. Moles of water cancels, leaving you with grams of water left over. So if you have 50.0 grams of this reacting with excess amount of oxygen gas, it's going to produce 34.6 grams of water. What I would do at this point in the video is pause the video and try these out on your own. It says in the reactions listed below, if 155 grams of the reactant listed first reacts with an excess of the reactant listed second, then what mass of the product listed first will be produced? So in these problems here, You know how much of the first reactant there are. You're trying to figure out what mass in grams of the first product will be produced. Go ahead and pause the video. Take 10 or 15 minutes to try these problems out, and I'm going to give you guys the answers right about now. So how did you do? If you got these all right, then you're pretty good at MassMass Stoichiometry. If you like what you see, go ahead and click that little bomb in the bottom right hand corner, and that will subscribe you to my channel. And feel free to leave any comments or questions down in the comments section down below. And I really hope you guys found this helpful.